Welcome to Math in the Bubble with your host, Mr. Daly, for episode 5. Today on the episode, we will be uh, learning about solving for other shapes other than prisms like pyramids and cones. So you've got that to look forward to at the end of the day of the lesson. Um, and But to start us off, we are going to do some regular prisms and find the volume of those. Alright, without further ado, I'm going to get started. If you want to do these by yourself without me, put the video on pause, put me on mute, work in the background, I don't know. But I'm going to do this rectangle to start off. Alright, all the units are mixed up. We've got centimeters, we've got meters, we've got millimeters. So we want to get those all uniform. So seen as meters are our base unit, they're the standard unit that everything gets related back to, we'll change it all into meters. So 1,300 millimeters, we would divide by 1,000 to get to meters, so this is going to be 1.3 meters. And centimeters, we want to divide by 100 because there's 100 centimeters in a meter, so that would get us to, I haven't flipped my screen around, that's why it's so hard. So we got 0.62 meters over there, 2,4 and 1.3. So the volume of the cuboid, is 0.62 times 0.24 times 1.3. Let's put that in our calculator. 0.62 times 0.24 times 1.3, 0.19344. 0.19344 meters cubed. VC for short. Alright, next one we're going to head on to, we may as well go back to this nanometer or micrometer triangle. So let's put our 40 millimeters into micrometers. So this centimeters. Did I say centimeters? Sounds about right. I'm always mispronouncing words. Alright, so what I just did there, I changed to micrometers, the one with the mu. So this is a really long, thin triangle. I was trying to make like a nanobot type thing. You can imagine some sort of nano snake that might help heal you one day would look like this, and you want to work out the volume of it. Who knows? Well, not nano snake, micro snake, robot, micro snake problem. Okay, so let's find the volume of the robot micro snake. So we got this isosceles triangle, right? So there's a right angle triangle in there, and we can use that to find our height. So if I redrew that triangle, we would have 4 micrometers because we're halving 8. We'd have the H side, and then we'd have 12 micrometers on the other side, because remember those two lines mean that those sides are the same length. Right, so to work out H, we need to use Pythagoras. So I might just use that one. Pythag, H equals square root of the big one squared minus the small one squared, because we're finding the short side. So that's why we use a minus in there. Leilani just write, do you have to write the first M differently because they're both millimeters? So micrometers, I don't know if I've done it clear enough, but the M, it looks like a curly U. Micro. So you do micrometers. Anyway, back to here. Let's do that on the calculator. Square root of 12 squared minus 4 squared, close bracket, equals 11.31. 11.31 micrometers. All right. This is getting very busy. So all of that was to work out the height. So remember, for a prism, we want to do the volume equals half base times height times times the length. So what we want to put into our calculator is 0.5, which is a half, times our base, which is 8, times our height, which is 11.31. We just worked that out. And we're also multiplying it by our length, which is 40,000. So 40,000 micrometers is the same as 40 mils. 40 millimeters. And these are all in micrometers, so we'll get micrometers squared, cubed. Alright, 0.5 times 11.31 times 40, oh, I missed out 8, we just add that in, times 8 times 40,000. $189,600 equals 189,600, which is actually 1,809,600 micrometers cubed. Ooh. And if we wanted to put, if you think about how small a micrometer cubed is, well, we need to think of how big. Let's just do 1 millimeter. So this is 1 millimeter cubed, but each side is 1,000 micrometers. So it's 1,000 micrometers times 1,000 micrometers times 1,000 micrometers. So that's 1 times 10 to the 9 zeros, millimeters, micrometers cubed equals 1 millimeter cubed. And I mean, a millimeter cubed is already a tiny, tiny thing. So if we divided that by 1 times 10 to the 9, that would get us divided by 1 10 to the 9, then we're going to get 0.0018 millimeters cubed. So this microsnake, robot microsnake, is actually a very, very tiny volume. Maybe that'd probably be like a grain of salt. All right, something a little bit easier. Millimeters and kilometers. In fact, these are actually more separated than micrometers and millimeters, but at least it's not new units this time. So the volume of a cylinder is going to be the area of the cylinder face, so this area, times the length, which is our 60,000 kilometers. So what is the area of the cylinder? Well, we got that new formula pi d squared over 4, so that's the same. The area of the cylinder is pi d squared over 4, is also the same as pi r squared. All those things in yellow are the same thing. We might just go back to the radius one today. So if the diameter is 5 millimeters, our radius is going to be 2.5 millimeters. So each of these will be the same formula, just using different values. So let's do this. Pi times, oh, sorry guys, I forgot, we got to put this into millimeters. So first let's put it into meters. So 60,000 meters, 60 million meters is the same as 60,000 kilometers. And then going an extra step to put into millimeters, you just add another 1,000 on. So it's pretty easy to change between SI units because you just tag another lot of 3 zeros on, except for centimeters, but we want to phase centimeters out because they're for primary school kids. So in our formula, pi times radius squared, so our radius is 2.5 millimeters squared. 2.5, actually I said that wrong, it's 2.5 squared. So and then multiplied by 60 billion millimeters. And if we wanted to write 60 billion as well, we just count the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be 6 times 10 to the power of 10. That'll just make it a bit easier to do on the calculator. So shift pi times 2.5 squared. So that's just the radius of the front face, and multiply by 6 times 10 to the 10. Woo, that's a big number. 1.1778 times 10 to the 12 millimeters cubed. All right. Oh, I forgot to give you a scenario for what this thing might be. Well, it's 60,000 kilometers, so I was thinking this is the fiber optics in New Zealand. I have no idea how accurate that is, but you could think of all the fiber optic cables in New Zealand. They're little 5mm cables. What would the volume of all those fiber optic cables be? So millimeters cubed. We can't really conceive of this unit as it is, so let's put it into meters cubed. We can sort of perceive what a meter cubed is. Like it's something that's a perceivable value. So let's think about how that would change. So 1 meter cubed is going to be 1,000 millimeters times itself 3 times over. So that is 10 to the 9, because we've got 3 sets of zeros multiplied 3 times together. So if we wanted to change that into millimeters, then we're simply just going to take 9 zeros off our answer. So 1.178 times 10 to the 3 meters cubed. So 12 minus 9 is 3. Sorry, I don't actually think that was a very clear way of showing that, but you live, you learn. I'll think about a better way of doing that tomorrow. Okay, so 10 to the 3, that is 1,000. So if we multiplied this number by 1,000, it would shift the decimal point 3 times. 1, 2, 3. So our final answer is 1,178 cubic meters of fiber optic cable in New Zealand. So that's like if you had a box and it was 1 meter squared on the front, and that box went for 1.178 kilometers. So it's fairly big volume. Hopefully that helped you perceive it. Probably not, because it's a very confusing problem, Mr. Daly. Alright, so this question here, it's very artistic. The jelly bean rod. So we can calculate the volume of this shape because it's the jelly bean has been extruded, so that that area is the same. If I cut it in the middle, it would look the same on the front. So this is a prism, even though it's not a regular shape on the front of it. So we can just use our area of the face times the length is going to get us our answer. So it's just going to be 0.036 meters. Oh, there's an extra 0 in there. 0.0036 meters squared times 2.5 meters. 0.0036 times 2.5. 9 times 10 to the 3 is going to be 0.009 meters cubed. Remember, when something's 10 to the negative 3, that just means 3 zeros. So 9 times 10 to the negative 3 3 zeros. So if it was negative 5, there would be 5 zeros, and you count the 0 on the other side of the decimal point. Pro tip. Whew, okay, I think I actually spent way too long on that, but we'll try a pyramid and a cone. So let's just do it on this one. Pyramids and cones, they have a very similar formula. So to get a pyramid, volume of a pyramid, you have 1/3 of the base area times the height. And that actually is the same for a cone, but when you think about what we need to sub in for a pyramid and a cone, it's slightly different. So the height is this. I might just highlight it. So this is the yellow part is our height. So it's from the very center up to the top, and the base area is, try not to overdo that, is that part of the pyramid. And the 1/3 is just because all of the shape is tending to a point. It just so happens that it's 1/3 of that volume. If you just did the base area times height, you'd basically just have you'd have a cube. So the 1/3 part is because it all gets squished into that point at the top. But I might just undo all of that because it's getting a bit busy. And a cone works the same way. So the height of a cone is this distance from the very center at the bottom up to its point. So that's the height, and then the base area is well, it's not an oval. It's a circle, just at a different perspective. So it's slightly different. Well, actually, well, it's exactly the same, isn't it? Um, but with a cone, you are usually given the radius and oops, and the height. Yeah. And if you're wondering where that 1/3 comes from, calculus, that's where. And you'll learn about that in year 13. So you got that to look forward to. Um, uh, so the base area is the width times the length. Um, so really you can rewrite the pyramid formula as one, let's not do red, it's a terrible color. 1/3 times width times length times height. So that's pretty easy. And for the cone, well, the base area is a area of a circle, so that is pi r squared, and then times height. So usually you'll see something similar to this on your formula sheet. You won't see the pyramid, the one above, but I just wanted to show you that they're actually the same. So you can do this for a hexagonal pyramid that might look like any sort of weird sort of pyramid that goes up to the point in the middle. Is just going to be 1/3 times the base area times that height up to the top. But generally you only get pyramids and cones at year 10 or even at many other levels. But that third, it actually works for any sort of shape that's been coned up to the top, pyramided up. Alright, let's do one problem. So I might just, let's Google the dimensions of the Pyramid of Giza. I've heard a lot of it's the first thing that comes up. Okay, let's just take that stuff. And chuck it over there. Alright, I took this stuff off Google. The height is 146.7 meters. Height equals 146.7 meters. The length 230.34 meters, and I'm assuming it's the width is also the same because it's a square. So really, we can just do L squared instead of width times length. So the volume of the Pyramid of Giza, volume Giza, the V Giza, 1/3 times 230.34 squared times 146.7 meters. One third, oops. Do you have to press it first? Okay. 230.34 squared. I'm squaring it because I don't want to have to write 230.34 again. That's a lot of effort. 146.7. Ooh. 259. 2,594. 2,594. I've just done it to 3 significant figures. Meters cubed. What's happened to my Twitch chat? So yeah, that's a crazy amount of volume. I wonder what the weight of that would be. You think about a cubic meter. If that was water, then 1 cubic meter, that's 1,000 liters. We learnt that the other day. But the other interesting thing about units and SI units is that 1,000 liters of water is 1,000 kilograms. So, but that's not the case for all things, because well, why do rocks sink? It's because they're way heavier. They're way heavier, way denser than water. So actually 1 cubic meter of granite or limestone will have a different weight. So I might just put that into Google, see what we come up with. 1 meter of granite. I think most of it's granite. Weight. So it's saying that it's 2,691 kgs per meter cubed. So the weight of, oh, we don't want the volume anymore. We want to do the weight of the Giza is going to equal the volume of the Giza times our this is called like a density. 2,691. 2594000 times 2691. Hopefully my answer's still on the calculator. That's good. 2691. Woo! How many zeros? Digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, don't do that. Whew! That's how heavy it is. Okay. The cone, let's just, I might just leave, the cone is going to be the question that I'm going to see if you guys can work out. What would a road cone be? They're about 80 centimeters tall, and the radius is about, let's say, 20 centimeter radius. So here's all the information you need to find out the volume of a cone. It's just the radius and the height. So I'll just leave that up there for the next 5 minutes, and I'll just chat with those in the Twitch chat, and post your answers if you can calculate it. So this is a road cone, and anyone still out there in the Twitch chat? I haven't seen anyone post anything new in a while. Good. Hey, Rosie's there. Have we seen Rosie on the chat before? Can't remember. Yep. Well, good to see you again, Rosie. And I thought I'd just talk about that. Seeing as there's nothing on Monday, I don't really want to give you homework. Just if you can get this question, then that is your homework. All right. The fact that you tuned into this is good enough. What else was I going to say? I understand you, brah. Thank you, Rosie, for delivering life experiences to the class. But once we get back into class, you won't be able to drop any more bruh. No, I don't really mind. Doesn't matter. Sup, Olivia. Only 8 people. Should I text their parents again. All right, I might do a little roll call before we leave. Um, so we got William, Indiana, Rosie, um, Olivia. Um, who else has been on there? Is Eamon out there? Is he lurking out there? Leilani's in there. Who's HU 19124? Yes, you are here, but who are you? Ah, Huey. Good to have you, Huey. And Amelia. Oh yes. Also, to end the stream, I have some comic relief, so I'll get that ready on the other window to bring through. I was thinking of doing this more often. I could slip in a little bit of um, comic relief every once in a while. So let's play this video. It's a delivery from UPS. uh, anyway, that's that. So that'll be the end of the lesson there.